Hello, I'm Ettore, a Rocketeer, and today I interview the Swiss rocket team, EPFL, which won the EuRoC award for the hybrid 3-kilometer flight. How many are you in your team?
Officially in the team we're about 200 members, but I think right now we're a bit less, around 150, 160. The team story and mission. The team was founded in 2017,
yes.
And it was founded by a group of students that were participating the year before at the Split America Cup, with also students from ETH Zurich, so with students from Aris. And that's the team split up to create the EPFL Rocket Team and Aris. And the mission of the team is to introduce students to to initiate them to complex engineering problems here in the studies in order to get them ready for the industry. Because actually, the studies at EPFL are quite theoretical, and so the founder seems that they needed practical experience, and they choose rockets because rocket is great.
Could you please introduce yourselves?
I'm Alexandre Chappuis. I'm the president of the EPFL Rocket Team.
And I'm Florent Gaspoz. And I work 2 years in. I will spend my life in the EPFL Rocket Team working on propulsion, basically.
How is it to study in university? Can you study in English?
Courses can be in English or nearly all in the master level. And in the bachelor level, I think you have about half the courses that are in English.
So sometimes the choice is given between the French and English, but there is some course in bachelor when you only have French.
You can study it if you don't speak French, I think, but you still have to learn it if you are in bachelor.
What are the job opportunities after your university?
Basically, the EPFL has been founded to guarantee talents for the Swiss industry. So it's one of the best schools in Switzerland, so you can work pretty much everywhere in Switzerland. And it's quite renewed also around the world. So something maybe more about where you can work after doing the job in our team. Really wants to recruit us after our studies, because they think that this particular fund that we have is really beneficial for them. You can work after our teams to Beyond Gravity or to Upgrade Technologies and Maxer and Kistler, this kind of companies.
What are your team's goals?
Since until 2021, the summer, the goal was just to build rockets and win the competition, the Spaceport America Cup or EuRoC. And last year we redefined the ultimate goal of the association, and what we want to do now is to go to space, so to do a space shot with a bi-liquid rocket engine. We try every rocket because every year we build a rocket for competition, and we try to develop a new technology with every rocket that will be useful for the space shot. So, for example, this year we're going 9 kilometers supersonic just to gain experience on all the supersonic regime design characteristics, etc. So yeah, the ultimate goal is to go to space, and we have a secondary goal of building a lander like SpaceX with the project Icarus.
When do you plan to go to space?
Date we gave ourselves is about 2027 or 2028, something like that.
How do you recruit the members to your team?
We have one big recruitment session at the beginning of the year in September, where we done majority of our recruitment. Last year, and this year as well, we enabled some candidates to also enter during the year, but it's really more case by case, and it's not we don't have 20 people that are coming during the year. It's really if you know a friend, you can join maybe. And yeah, so one big recruitment session, and then we do interview for each candidate to place them in the right project, in the right position. Concerning maybe our candidates, motivation is key. I mean, really, you don't have to know a lot of stuff. It also depends on the position that you want to fill in, but mostly you don't. What you really need is motivation. If you are ready to put 10 to 20 hours per week, you will be able to do something, and that's great. If you don't, even if you're skilled, it will be more complicated. Concerning actually, it's not needed to be a university student at all to join our team. We have about I think 20% of our team or 25% of our team which is not from EPFL, from other school in the area, and that's really great for that. And that's also one of the reasons, or that's also the thing that we try actually, because we need a strong communication team, marketing team, and so we try to recruit from other school for that kind of skills. Yeah, otherwise you just need to be a student to be part of the team.
What can the members learn in your team?
So many things. The Rocket Team is really a great experience for so much things. Particularly, there's certain things I don't see how you can gain this experience apart from working in very specific part of the industry, the example I want to give is like operation on the field. The experience of being on a military base, having to assemble a rocket, assemble a rail, assemble a ground station, launch the rocket in a few hours. It's really something really unique. See, like have an introduction of how maybe a technical company work, like with the subsystem, sub-team, you have to do your job, then report to your leader, that report to his leader with the system engineer. So you really have an experience of how it works in a big technical company. And obviously the teamwork, because you only do a really tiny part of the rocket, so everything has to work together.
In our approach to be really professional and to be and to follow the same methods that ESA or NASA or other companies. And that means also that we do a lot of documentation. Yeah. And so for that, it's also a training for career actually, because when you'll be engineers, you have to do this kind of documentation. And so also for that, we have done, I think, 1,600 page for our last rocket for documentation.
624. 1,624.
Oh, yeah. It's because it's something that it will be asked afterwards in our future careers. And we also find that it's really important for actually knowledge transfer for the future teams. Because if you want to go to space, as we are still quite a young team, we will need knowledge transfer. Otherwise, it's not possible to go to space every year if people don't know what they're doing and start from without any knowledge transfer. So yeah, and also our member, I think it depends, but our members stay minimum 1 year, I would say, or 6 months if they are doing a credited project. Recognized by the university, but I think minimum is for 1 year, and it can go up to 4, 5, even I think 6 years.
1 or 2 very old people in the team.
Yeah, and that's it basically. And also maybe a bit more about recruitment as well. We have a function project that also enable first year bachelor to actually have an introduction about rocketry and teamwork. And that's I think something really interesting, because that they don't have all the difficulty of a more technical rocket or more technical project, and are still able to do a bit of making and prototyping. So also something that is interesting.
But basically, what we did is during the first semester, the people that joined the formation project called Space Race, they had one workshop per week about electronics, about rocketry, about composites. And during the second semester, they were in small team, and basically we did a small internal competition when they had to build a small rocket in teams and launch it at the end of the semester a few weeks ago.
How do you manage your team?
In the technical side, we have a few projects. So the name we gave is project. We completely separated system engineering and technical management. So I have the competition rocket, the bi-liquid project, the control and landing project, and the formation project. So every of these projects has one or multiple system engineers that oversee what happened in the project. If not in every project, but mainly in the competition project, under the system engineer, you have the team leaders, and there is one team leaders per subsystem. So the rocket is divided in subsystems, so propulsion, avionics, structure, ground station, and every subsystem has a team leaders that report to one of the system engineer. And under the team leaders, there are just the regular members that do the practical work on the rocket. Every project has one or multiple representative in the committee of the association that have members from every pole of the association, just to have a global idea of what happens and to manage it well.
Maybe also more on the management side. So basically, as Florent said, we have the committee that actually is the head management of the association, and we also have a management pole. So it's managed by the vice president and the president, and this pole is divided in I think 4 or 5 teams, which each one has a team leader. So it's sponsoring, communication, logistic, and human resources, with also other finance on the side. This condition was quite new for us, because we're used to have size of the management pole. Yeah, that worked quite well, and it was also to have actually quite a good communication outside the team, and to be able to have kind of resource on that as well, because actually it's important, because when you do a project like that, you need finance, you need funds, and for that, sponsors are interested in your communication. It's great if you do amazing rockets, but if you don't communicate, well, it's a shame, because you will be able to do even more amazing rockets if you communicate to do that, because sponsor will be then interested. And also maybe on on the project management, on the tools that we used. So for knowledge transfer, we have the documentation and a wiki that we have developed ourselves, which is quite important. To communicate inside the team, we have Slack, manage and planify. We have Monday that we use, and also we have also quite a number of members that don't speak French in the team, and that's all right. Like we try to have every communication, official communication in English, and that in review, all our reviews are done in English. So you can't come to the rocket team without speaking French. It's possible.
How's the experimental rocketry community in your country?
We are quite lucky in Switzerland, let's say, because there is very few AAA rocketry association in Europe, and I think we have the biggest one in Switzerland with the prefect that actually can get real motors. So there is quite a bit of rocketry community in Switzerland because we have the possibility to launch quite big rockets. In addition to that, so we have two big technical universities, EPFL and ETH, and we have the EPFL Rocket Team in the EPFL and ARIS that maybe you know in the ETH. So we have like two major rocketry team in Switzerland, which is really a lot. If you look in Europa, some country does not have one or only one, and we have two big, so it's quite developed in Switzerland.
ARIS, like we are also a lot in touch. Like I said, we are not in touch with ARIS because it's our sister team. So we do also a lot of reviews together, and we help each other as well. Like like if they come to our reviews, we come to theirs. And also things like the space, the rocket community outside these two teams, they have like two launch sites in Switzerland, at Calbon and Saint-Ternier, with a maximum altitude of 2,000 meters. So that's something. But it's still not enable us to launch big rockets and supersonic rockets at all. And for that, we actually have only one launch communities in Portugal at the competition. There's a question about how do we feel about the future of space entry in Europe. Like in Switzerland, we don't have any political, I think, like it's politicians don't really want to develop any rockets in Switzerland. And so for Switzerland, I think that the new space will be concentrated in satellite making or this kind of stuff, and not about the launchers, so to say. But yeah, we have like a lot of new space companies like RFA, working for Gaspoz in Germany, or Aerospace, also in Germany. Also, and we have our developers for space in Switzerland, a hybrid propulsion for space in France as well. So a lot of things are going on. But yeah, we will see if we're able to beat the US in some of these opportunities of launch and the markets.
Are you a part of the OpenLaunchInitiative?
I believe, yeah, we are. Like I've joined a call about this opportunity, this initiative. It's interesting, and we'll see what we're able to get from that. And so yes, and like right now we're testing our rockets. Like if possible, we're testing our rockets in Switzerland, like with the maximum altitude of 2,000 meters. And if it's not sufficient, we are just simply not testing our rocket as a whole, just testing the different subsystem. And yeah, basically, so it's a thing for us because we don't have any other launch opportunities than in EuRoC, or if we want to go out to Mach.
What we try to do is to test small scale things, what we can test in small rocket in AAA launches, because it's pretty hard to launch our main rocket in these launches. Maybe we will done it in the future, but we done it one time. We launched a rocket on a military controlled field with the Swiss military in the mountains. That's one way of testing our pretty experimental rocket. How
do you promote your team?
We have on one side like all the social media stuff. So we try to be quite active on Instagram, Twitter, Facebook, and LinkedIn as well. Yeah, basically like in terms of situation, we try just to tell what we are doing basically, and to just give updates of the project and to do promotional posts for the sponsors as well because it's also important. We also have a YouTube channel, but I think it's mostly used to just post on videos. So we don't have any active community on it. Actually, like we want to post a video, and okay, we post it on the channel, and then people are looking at it. I think more like through the posts that promote it in Instagram or LinkedIn. In terms of storytelling, like what we want to say is that we are students. Like basically, we are students doing professional stuff in a professional way as well. Like we are making great rockets, and that's also able to learn a lot. And so we also try to sell us as a Swiss team representing Switzerland abroad, because it's also interesting for the sponsors as well. And we also try to have quite presence in the other media, like at the TV or in the press. For example, last year when we won EuRoC, we had like 2 minutes in the 19h30 of the FTS, so that the main television channel of Switzerland, which is quite interesting and quite nice. We also had a front cover in the 24h, which is like one big newspaper in Switzerland, like or in the French part of Switzerland, because as I think you might know, Switzerland is divided like in 3 different regions, so the French part, the German part, and the Italian part. And so sometimes it's hard to cross these boundaries when you try to have news, because like the German part will be more interested what will be going on in the German part, and so we'll not really be able to cross this Berchtesgaden, as we always call it. And so I think the main ones in the French part of Switzerland, so near Lausanne and maybe Geneva as well. But not a lot in Zurich or others. Yeah, and for as I said, for internal communication, we have Slack basically. We also have email list for important information. And yeah, sometimes it's quite difficult to actually know if the members have got the information or not, because it's just a huge team, so you can't really tell. But it's working pretty great, so I think it's okay for now at least.
What are your experiences at EuRoC?
Yeah, the experience was really great. There was the COVID, so the team hasn't gone to a competition since a long time. When we go to EuRoC, the last time was the Spaceport America Cup in 2019. So most of the members had never seen a competition, so that was very great. And this year we'll participate in the COTS 9 kilometers category, like I said earlier, to handle a bit of the supersonic regime. We will try to go because we have the money. We bring the maximum people that we can, so 30 people. We don't really need 30 people to launch the rocket, but just because we can, we do it to give experience to people, to what is the competition, and because just people want to see the rocket launch simply. The difficulty we expect this year is as 9 kilometers is pretty restricted. The launch window are pretty small and at very precise time. So we will have to need very, very prepared. And when we have the 10-minute launch window, we can launch immediately. And that's the main challenge on site, I think, just to be extremely ready. Because I think last year, at least one of the 9 kilometers team couldn't launch because on the last day they wanted to launch, there was clouds, so they couldn't launch. So we really want to prepare to launch at the first launch window.
We don't have any, only students will go. We don't have any advisor members that will go with us, basically. And it's also because the team is quite self-managed by students. We don't have a lot of intervention by professor or doctoral students. It's pretty self-managed by students. It's actually quite interesting and great, I think. Last year, because we talked about a bit about this year, last year, it was, I think, for all of the team, an incredible experience. No zero competition for during 2 years. COVID strike, it was quite difficult to work on the rocket, quite difficult to stay motivated. But yeah, the competition was really great. For a second time, it was amazing what they were able to produce. And for us to launch our rocket, launch Valve 2, after 2 years and a half of work on hybrid rockets, it was crazy, and the success that we have, and it was amazing. And there's a moment, when you see the main parachute deploys as a nominal apogee, and everything works as planned. Yeah, I think for all the team was one of the best moments maybe in their life. I don't know.
Yeah, the team went crazy when the main deployed. It was insane. Did you see the after movie? Yeah. Okay, so you have quite an idea what happened.
Yeah, and I think last year, DanSTAR with the PublicRelations Design, the huge PublicRelations rockets. It was quite impressive to see, and okay.
The most impressive things for me, just the liquid rocket is insane, but they launch at the first launch window 5 minutes after the start. They was extremely on point. They were ready at the first launch window. They launch. It's a liquid rocket, so it's very complicated. So I was really impressed by that, and if they come this year, we'll have to look after them.
Exactly. And Aris also was quite impressive with a huge rocket picker. Just this huge rocket. It was amazing, and to see like this. I don't know how long it was, but like
6.5 meters, I think.
6.5 meters. Yeah, so okay, quite amazing to see. The Norwegian were also quite impressive with a thin rocket able to go to 9 kilometers. It seems to have like really like sweet design. The rocket also was quite beautiful as well, and for me also the Italian, like I think it was the second competition or the first competition, and they were able to get a nominal flight. We know actually like in the story of the EPFL Rocket Team, we also had one issue in competition and in flight. It was the deployment of the main parachutes, and so we know that it's really difficult to do. So that's also why we are extremely happy to achieve that last year, able to do a nominal flight for the first competition, I think. It's also quite an achievement, so congrats to them as well.
How is the technical review process at EuRoC?
We arrived on Monday, I think, on the paddock, and Monday was just about preparation. 3 main reviews. So the first one was the judge of the competition went to our stand, like where the team was and the rocket was, and they stayed there for about 1 hour, 1 hour and a half, and they had the big list, I think about 50 points, that they had to check on the rocket. So just they asked us, we could show them on the rocket, and every of these points had to be green for us to launch. They could be yellow, and in this case we have 1 or 2 days to mitigate them, or if we had any red points, we couldn't launch. So they went on all these points on many safety and technical consideration. And at the end, we just had 2 yellow points. It was we had to sign our procedure and we had to do fit test on the rail. So it was easy to mitigate. This was the day before launch, so the 3rd day of the competition. The day before, this review was done by engineer parts of the jury, and the day before we had like most of the jury came to the stand, and just for a shorter time, just we had to explain them the basic concept of the rockets. So that was the 2nd day. The 3rd day we had the technical review, the flight readiness review, and the next day on the launch site we had the launch readiness review, where they checked that we mitigated the yellow points and that the rocket was basically safe to fly. They gave us on site a few tips on some line management for the rocket that we applied.
And when actually we told him about the resume version, he was like, okay.
The short version was about 500 pages, I think.
600, I think. And basically what I know is that the jury quite appreciate the report, but they just think it was just too long, and they wanted something, I think, more resume, more condensed, I think.
Do you want to join other rocketry competitions?
In the past, we also were competing to the Spaceport America Cup. That was always were the 2 competitions that we were participating in, like Spaceport America Cup and EuRoC. And we don't have any competition in Switzerland, so we don't participate in any of them, basically. And we decided this year to not join the Spaceport, mainly due to calendar reasons, because the Spaceport is in our exam session, and so it's really for us complicated to go, because like a large part of the team has exams in Switzerland, and they can't do it remotely. And they have to be in Lausanne for that. So yeah, they're stuck in Lausanne, and so we can't have the right team to launch the rockets. So it's a challenge. Also on top of that, we also are in the process or in the thinking to reduce our emission of CO2, and we don't think that going to America by plane for 1 week is something that is manageable in a sustainable world. So we try to reduce a bit of emission for that as well. And also we also wanted to promote EuRoC as well, because like EuRoC was partially initiated by our team basically, and so like we also want that the competition actually works, because we think that it's really super great to have an open competition for European, and not every time that it's about rocketry go to the US. And about the importance of competition for us, it's also mainly to test our rockets basically, because we don't have any other opportunities to test them. And it's also about to have mediatic and presence, and that's also important. So that's the 2 important points for competition for us. And so EuRoC has filled this 2 points quite nicely, and that's also we are only going to EuRoC.
How do you build the rockets?
The rocket from this year is called Wildhorn. We have the tradition to name every of our rockets with name of Swiss mountains. So Wildern is a mountain in south of Switzerland. The principle of the rocket was to go as fast as possible for as long as possible to test some effects in the supersonic regime. I think we had to change our engine, so we go a little less faster than initially planned, but it's like Mach 1.8 and supersonic for at least 10 seconds, something like that. So we'll have plenty of time to see what it's like. Some interesting features. The two I think of that I really like is that we have the rocket is mainly made of carbon. But the tip of the nosecone is PTFE, and we chose this material because it's a lot more heat resistant than carbon, and as it's the tip of the rocket, it will heat quite a bit. Carbon does not let radio emissions in and out, so we put the egg timer, so the official computer for the competition, in the tip, so it can communicate with the ground. And the second feature I like is the main. Three features I like. So the second one is the main coupler of the rocket is a screw coupler. So basically we screw the rocket together, which is quite unique, I think. I haven't seen that a lot. So really like a M100 screw. It's pretty insane. And the third thing is we have a mechanical separation like last year. So no black powder or CO2, just one of the coupler of the rocket can actually decouple in flight and let the parachute out. So that's the main features.
Wildern, I think, cost around, like if you count everything, so test opportunities as well. So for the helicopter, for the tunnel that we have, that for the opportunity of to test it in the tunnel that we have as well, I think it's around 100,000 Swiss francs. So
that's with value. It's not the cash value. It's everything the company gave us free.
We also have other projects that we don't talk about. So the Hyperion project and Icarus project that also cost quite significantly. And so yeah, I think the total budget of session is a bit more than 300,000 more or less, with also the license fee. So, for example, if a company sponsors a license, it will be taken in this 300,000, things like that. Yeah, it's a lot, but in the same time, like we have, it's what is needed to do a rocket in Switzerland as well, because Switzerland is also quite expensive. There are many Swiss companies that sponsor us in the engineering field. Our two main sponsors are Gravity and EuRoC Technologies, are the two main aerospace companies in Switzerland. And the supporters, for example, carbon manufacturing, so the manufacturing of our carbon tubes, and also finance.
What do you have in your workshop?
Oh, so but basically I'm in the place we call the makerspace. Like I'm in the electronic room currently, but it's a really big room with a lot of tools and machines that we use to manufacture our rockets. And currently there's a structure guy in the workshop working on the payload integration tube. And I saw also the tip in PTFE I talked a few minutes ago. It's just like 2 meters away from me, actually. So and this is the place when most of the magic happen, I want to say. And for example, tomorrow we have an integration test of the rockets of the operation team. All the operation team comes here, and we assemble the rocket to just train to do it fast in the EuRoC.
Do you have plants in your workshop?
Plants? What do you mean by plants? Plants?
Yeah.
I don't think so. Do we have plants in our workshop?
Because I see something green there.
Me?
Yeah.
Yes. That's
since when we have a plant in
okay, so like the makerspace isn't like a private place from the EPFL Rocket Team. Most of the people are from the EPFL Rocket Team, but there was some other people. And there's a guy there that has a startup that has some basilic, I don't know, like the thing you basil, yeah, okay, and it's the basil plant, and actually we have to water it every day because he's in vacation. So yeah, that's actually a plant. I go because I wanted to show you the engine and the tip, but I haven't found them, so sorry. I think that they are in cardboard box somewhere.
What materials do you use to build your rocket?
All the airframe this year is made of carbon, except from the tip. So the carbon tube, we did them in APCO, one of our sponsors. So during 1 week, a team went there every day and manufacture the carbon tube like they do in the industry. With the pre-prepared carbon and an autoclave, so the big machine that goes that pressurize the tube and heat it to cure it. And we also did the fins in a similar with a similar technique. The carbon part of the nose cone. Couplers of the rocket are in aluminium, and we designed them on CAD. The workshop in EPFL manufactured them for us, or one of our sponsor, Maxon. For the rockets, that's about it. So really this year it's all carbon. Last year it was a bit different. We had flax fiber for one of the tube that was done in one of the workshop in EPFL, and we had the aluminium tank for the hybrid engine that was designed by us but manufactured by one of our sponsors. As I mentioned, I think the engine is a COTS one, so we buy it. So we don't just have the casing and we fill it with the propellant. So not a lot of work on that, but we're working currently on a bi-liquid engine that is also just right there that we manufacture ourselves on the machine here.
What software do you use to design your rockets?
CAD. We chose to use SolidWorks. We have access to CATIA with the EPFL, but we just recent, and SolidWorks actually is a sponsor that gave us, I think, 200 or 100 license. So all members of the team can have a student license of SolidWorks, which is pretty cool because we can do thermal and fluid analysis with it as well. PCB Design, we use KiCad. So we try to unify the software on the team just for everyone to use the same. So yeah, CAD, SolidWorks, PCB, KiCad. For the simulation, we use OpenRocket, but we have on RASIRO. All the previous year have developed and customized a simulator, like they done it from scratch. And every year it's getting better, and we just correlate the data from OpenRocket, from RASIRO, and from our own simulator just to have the final simulation. So yeah, that's developed software in the team. We will use a bit of MATLAB and simulating for simulation, mainly on the engine side for last and next year.
And also concerning like simulation, like structure simulation or fluid simulation, we don't only use SolidWorks. We also use ANSYS, so Florent for fluid simulation, and we also use Abacus, or also ANSYS sometimes. For structural simulation. We also mainly use Abacus for all composite simulation because that's how it was done in the past and we didn't change. Also license, also logistics that the software that we use to model the pumps that we're also working on, because our engine, like in our vision, the bi-liquid engine that we be able to propulse our rockets to space will have pumps. And so to develop that, we also use a license called Turbo.
Yeah, so we'll talk about a bit the propulsion in the team. So last year we did the SRAD hybrid engine. So the hybrid engine was oxidizer was nitrous oxide, and the fuel was 3D printed ABS. So we 3D printed 5 small independent grains and glued them together with a 7 branch star pattern. That was last year. That worked very well. This year we buy the motor. I think it's a 1560 Cesaroni. Hopefully next year we want to use the bi-liquid engine developed currently by the project Hyperion. So we just assembled the first engine yesterday. So Demo A1, which is a ground test engine, and we want to develop Demo A2 and maybe A3. So A2 is a flight version of this engine, which is ethanol and nitrous oxide, and Demo A3 is the same but with liquid oxygen. But I think if we go for the main rocket, we will first time we will use nitrous oxide, and liquid oxygen is for later. And we also have the B class motor that currently doesn't exist but are in development that use that have 5 kilonewtons of thrust, regenerative cooling, and not immediately, but at the end, electric pumps. And I didn't mention them, but the A-class motor have 1 kilonewton thrust. For the production of the engine, the hybrid engine was mostly SRAD, except from the casing that was the Cesaroni one. And for the bi-liquid engine, actually we manufacture it all by ourselves. It's composed of, I think, 5 main parts, and we did them all on the lathe and mill here at the makerspace.
How did you develop your own PCB?
For the avionics, for I think last 2 or 3 years, we have what we call the host board, which is a very adaptive board that have the memory and processing unit on it with sockets to add some little modules And on the modules, you could have GPS or telemetry or sensors. And the host board was like a credit project from 2 or 3 years ago. And this year, one of the team leader, the Avionics team leader, took the project, redo and modernize the host board. So he went from scratch with a new microcontroller. We did a new host board with the same principle, so with the computing unit and the memory on the board, and with 3 sockets per board to add some additional capacity. So I think we will have 2 boards in the rocket with 2 sensors. With every board will have a sensor additional board. One of them will have telemetry. The other one will have GPS telemetry in LoRa and in Wi-Fi to send a video back from the rocket. We want to have a live feed from the rocket, potentially from the side of the rocket and also from the parachute bay of the rocket, because at 9 kilometers we can't really. It's hard to see the rocket, so we want to have a direct video link to see the deployment in real time. And how do we test our electronics? We want to fly it in a small scale rocket, so really take the same host board that will go in the main rocket, put them in small run, launch them in triple launches, and just see if it makes sense or not. Flight test is for electronics is really the best way and the way to go to test that. But we have also the payload that develop its own electronics. So the payload will have to use some cameras. So it'll have some electronics to record and save the feed from four different cameras, I think, but inside the rocket looking at the experiment.
How do you transfer data from the rocket to a ground station?
Main telemetry with the data in LoRa, I think in 868 megahertz, and the secondary will be Wi-Fi. I don't remember exactly the frequency of the power, but like very powerful Wi-Fi to downlink the feed from cameras. I think we could have up to 4 cameras in the rocket looking at the parachute bay or the surroundings, so that's like a lot of data. And we have also SD card storage on board to gather after the flight. And for the ground station, we'll have they don't exist yet, but we have ginormous antennas, and it's not 100% sure it will be ready, but we want to have an automatic tracker, the LoRa and the Wi-Fi antenna on it that track the rocket automatically. That can also be moved manually in case there is a problem. So that's the plan for the tracker.
How do you make your launch rail?
This year we don't bring our launch rail, so we will use the EuRoC1. And as the rocket is COTS solid, we won't have any filling or things like that to do. And we don't plan to charge the rocket on rail because we have like a lot of capacity, and the launch window are pretty small for solid rockets, so it won't stay for hours and hours on the pad. So we don't have any worries on that. But last year we manufactured our own rail and brought it to EuRoC, and you can see on the picture behind Alexandre the rocket, and this is actually our launch rail. So it's pretty massive. I think it's like 200 kilos with 3 legs and a 9 meters tower that we could extend to 12, but 9 was enough. With a complete ground station to fill the hybrid engine, the tank from the hybrid engine with nitrous oxide, and to ignite it. It wasn't mounted on anything, so we had to transport it pad with a van and assembled it. It took 1 or 2 hours really to assemble it. It's pretty long, but it was great to have our rail to have a bit of liberty of how we wanted to do our launch. And actually, it was a collaboration with the Aris team, so they also used our rail at the competition last year.
How do you make your recovery system?
We use a system of 2 parachutes, so 1 drogue and 1 main. The 2 parachutes are actually done by the team, so it's SRAD. All of it is SRAD, also the manufacturing. And so we have the drogues that deploys at the apogee, and at 400 meters, we have the mains that deploys. It will be also the case this year. And then, concerning how we made, I think, or how we designed them, it's mainly empirical method, I think. Like, we just use one method and we do them. And then, so our criticalities is a bit like one now of the highlight of the team, I think. So the first version was developed last year by a member. And basically, as I said before, he did not use any pyrotechnics or pressure guys. The idea behind it is just to have honeycomb wires with just to have 2 springs that are.
I think you mentioned in the slide the clamp band system. It's exactly that.
Exactly.
If you see what it's like.
And so you have so 2 springs that are linked with the honeycomb wires, and then we pass a current through the honeycomb wires that then melts, and the rocket is separated into. The system is tested one with a helicopter. thanks to one of our sponsors. And the parachute also tested with drone flights, thanks to another one of our sponsors. So testing about the ecosystem, we try really to test it a lot, even if we cannot test it in the exact condition of the flight, as we don't have a lot of launch opportunities.
Helicopter flight, like in 1 or 2 weeks, I think, and we will test the whole system. So it's like we had spare carbon tubes. Okay, I think they will use one of the spare carbon tube with the right mass, with the separation mechanism actually closed. They will launch it from the helicopter and hope it can, and then check the main. Like we said with in the past of the team, with a lot of problems with the main chute deployment, and last year it worked. So they used the same release system. So it's a 3-ring mechanism. I can't explain you exactly how it works, but it's the same thing used. Guys will jump with parachute, and it's the same mechanism that deploy that. They use a similar concept because it was flight proven and it worked well. And we have a little additional feature. Historically, all the main chute of the team were red with the big Swiss cross, and this year is no exception. So we also have a red main chute with a Swiss cross, and we hope it happened in the Portuguese sky like last year.
What payload do you have?
I really like the payload from this year, so I'm happy to explain that. Last year's we had the CubeSat 3 units because the rocket was quite big. This year the rocket is 4 inches in diameter, so it's really small, and so it shows the CanSat format. So I think it's 66 millimeters in diameter and 115 in height, 1 unit, and we have like 3 units or 2.5. Something like that. So it's like a long cylinder. And the science experiment is really cool. It's done by members of the team, but the concept has been developed last year during Belarus 2. And this year they done the practical realization. It's always done like that for payload. We always do the payload from this year and like develop the one from next year. And it's a study about how the sloshing of liquids in rockets. So maybe you know that in commercial rockets, big one, Falcon 9, if you don't do anything, the propellant can slosh, so just bounce around the tanks during the flight, and this can break the equilibrium of the rocket and just make it spin and explode. So they have, I think, baffles in the inside, so just big metal grid inside to manage that. But it's pretty heavy; it's just dead mass. And what we try to do, it's in the payload, we have 2 really small tanks with cameras pointing at them to gather the data. One of them is just liquid with nothing, and the second one is liquid with foam on it, because we found and we think it's possible to really mitigate sloshing with a foam on top of the liquid that will be like a lot lighter than metal baffles inside the tanks. So that's the scientific experiment. We don't deploy it; it just sit in the nosecone of the rocket.
Do you play Kerbal?
Yeah.
Yeah.
I can go on Steam right now and tell you the number of hours. I have 1,575.4 hours on Kerbal. So yeah, I play it quite a bit.
Yeah, I don't like. I think I played. I think I have like for 10 or 20 hours, maybe a little more. But yeah, I'm not near the level of like. It's a great game, but back in the days where I began to play that, I did not have the patience to learn a lot. So. And right now, I think a lot of members of the team that don't have the time to play a lot.
In the propulsion system, we have a lot of people waiting on the KSP2, obviously, and it's possible to learn a lot, like about orbital mechanics. I know a few people in master degree that took the orbital mechanics course, and they were really at ease. It was really easy for them because they had the feeling of how it worked because they just play Kerbal Space Program. Hard to imagine without trying it, but if you play a few hours on Kerbal, it's like really easy, and I know that they had a lot of. It was really easy for them this course because of that.
Do you have any big announcements or dreams?
We are anticipating to go with a liquid rocket next year, but it's not still yet 100% sure. It will depend on how the test campaign goes this summer. Hopefully, if it goes well, we'll be able to go with rocket next year. Otherwise, next year we'll also have normally our first hopper flight in our project Icarus, which will be great. The dream is to reach space by 2027.
Like the space shot is the big announcement or dream.
Yeah, exactly.
But we already told it, but yeah, that's the big thing.
That's a big thing. And we have a date. We'll see if it's be able to keep it or not. But we are quite confident that we can do it. Maybe with a bit of delay. We're a bit late. We'll be a bit late, but it should be manageable for our team to.
Just about the space shots. One of the system engineers did a master project. The base. He built the base of the concept of the bi-liquid space shot by searching a lot of things and building a really rough first simulation of the rocket. And he found that it wasn't that hard. Like the rocket, I don't remember the numbers exactly, but isn't that big and isn't that complicated to go to space with the bi-liquid engine. It's really complicated, so we agree, but like not as complicated as we thought. But he told us the main concern for him was the logistic of it. Like just to find a launch site where we could go a few days and launch to space, it's really hard. That will be the big thing. Or it's less hard if we go to the USA, but bring a 150 kilo rocket or something like that, liquid oxygen and extra to USA, that's not easy.
And also, we also try to also begin to look about the prices as well. And we can also say that about like in Europe, for spaceport in Europe, it's about 10,000 euros for one day. If you want to stay like 4 or 5 days, it's minimum like 50,000. So that's quite an amount. And we need to spare money for that and to be able to launch. So that's also the kind of thinking that you have right now. Think ahead for the funding, think ahead for where we launch it, think ahead for all the system engineering, and just do the right decision now for the future.
What are your personal plans for the future?
Working on this specialty will be great, mainly on launchers for me. I'm not some kind of interest in the satellite. I'm interested, but not like really passionate about it. And so SpaceX or other American companies are not possible for us because we are not American and we don't have any green card. So if you want to work on launchers, we'll have to go to the new space, to the European new space, which is great. So Rocket Factory Hasbro or Aerospace or other companies in Europe. Otherwise, I'm also looking maybe more about a career in the sustainable development, something like that, because going to space is great, but we also have like a planet to save a bit, or a system to save. We'll see what brings the future, but so space or maybe also any career in the sustainable development. In energy or something like that.
For me, I think I don't have a precise answer. It's really about opportunities when I want to find a job. But clearly, I will look to the big space corporation, Beyond Gravity and APCO, and to the small startup. Actually, the old member, like the founders of the EPFL Rocket Team, I know they are graduated. They founded a startup. For now, they're engineering consulting, but like they want to do space related things, and they already do some space related things. So maybe there, or maybe in the new space, European new space, we have a member working in like a whole member working in Rocket Factory Hasbro, for example. So that's something that's possible. I think I just see when I need to choose, basically.
See, because like we also have sponsors that are quite interesting company as well. So also it'd be interesting to work for them.
Basically, big space companies, they don't sponsor us because they want nobody buys rockets in the general public. They just do it because they want to recruit maybe some members of our team, and it happens that some of the members just go work there.
What are your favorite space movies?
No doubt on this one, Interstellar, because I don't know, like the music and the film, I just love it, so I watch it a lot. I like the fact that it's fantasy, but it makes more or less sense on the physics point of view. Like I like that they just didn't went full science fiction.
For me, I think it would be like I really like Star Trek, so I'm a bit of Star Trek fan. Like I've watched a lot, not all the series, but quite a few of them. Not making any sense, but they try to kind of making sense, like in the logic of the series. And otherwise, I've also liked Apollo 13. It was quite interesting to actually like. It's a really realistic film, and that's really great for that. I think that really we were able to see what happened cockpit or in the space cabin of Apollo. So yeah, quite interesting. And maybe also in terms of YouTubers that I watch a lot, Hugo Lizoire, which is a French YouTuber of space. It's quite nice to have like a recap of all the different news in the space industry when you don't have the time to look in details. You also have Conan that I watch as well.
Yeah, for YouTubers, I will say also Hugo Lizoire, because I think it's like the reference maybe in the French space related content on YouTube, because the video have really great quality, and you upload like 2 a week, so I don't know how it's possible, but yeah, it's really great. I follow him, I think, since 2017, I almost haven't missed.
Do you have any questions for me?
How do you become interested in the European student teams? And actually, why are you doing that? I really wonder that, because you begin you sent me an email, I think 3-4 months ago. And I was like, yeah, sorry, we don't have time right now. We are a bit, in the water. Yeah, it was for you a subject that was of interest.
So I'm interested in rockets from a pretty long time, and then doing some research, I found out that there was a rocketry association in my country, Skyward, and then via that we discovered that they went at EuRoC. Once we researched EuRoC, we found all of these European teams, and I think they're more interesting than American teams because they're closer, and also America has rockets from way longer than American teams are more well known, I would say.
I also think European teams, American are so different also in the philosophy of what they do. I think European teams are more focused on the design of the rockets. They also try to have a rocket that works for the first trial, like the first one that has succeeded. And American are more in a empirical approach. They try and it's failed, but they fix what has failed. They are more in an empirical approach.
Just because they have launched opportunities that are way easier than us.
Yeah, exactly. It's also I think quite interesting for us because every time that we were going to the SPAC, we were facing teams that were actually having this kind of launch opportunities, so a lot more than us. And it was quite essential every time to actually sometimes beat them because basically you have only one launch per year. It's just a competition. But then it's their 5th launch. Yeah, I also believe that the European teams have more budget than the American one, so it's a good thing for us. No.
And maybe I have 2 little questions. The first one is, you come to EuRoC this year?
I'm going to come as a visitor. I'm not coming with any rockets.
Yeah, but okay, that's nice. So you will see a lot of very cool rockets. The paddock is really cool because you have all the rockets exposed and you can ask all the questions you want. So that's really great. And the second one is do you build the rocket yourself?
Yes, they're not as big as, I don't know, DanSTARs or EuRoCs or Skywards, but they are rockets, theoretically.
And you actually, so what do you want to do later in your life? So you have a strong interest in space, I believe, because otherwise we will not be doing that. We'll not be interviewing a student team, but what a bit are you doing about the future?
So I want to make a rocketry team in my city. I've already started, and then later I'd like to have a company that makes rockets. And so being here and joining the interview, and I think we've ended this interview.
And don't hesitate to follow us on our social media accounts as well. EPFL Rocket Team on Instagram and LinkedIn as well. We are the most active there. We try also to post daily contents, but not our weekly contents actually right now.
Thank you, and bye.
And see you at EuRoC.
Yeah.